In today's lab, we're going to be using a pH probe, which is this little object here. Now the pH probes only do this once because in the next 4 labs we'll be using the pH probes to determine the amount of H plus ions that are in the solution. We always leave them essentially as alone as possible. By that I mean we don't want to have these things be moved around in the lab a lot because they're very delicate. So this is the setup that we're going to be using for any of the experiments where we use the pH probes. We'll connect them here to a 3-prong clamp, and then anytime we're not using them, we store them in their storage solution, which is just a little dilute solution of Ki essentially to keep the electrode there nice and moist. So if it dries out, it's ruined, and these are hundreds of dollars, so you're very careful with these. And I just realized that I'm not ready at all for lab, so give me a second. Okay, that's much better. So again, we're going to be using these pH probes for the next 4 labs, but I want to show you just the one time before we use them for lab 6 here, generally how they work. So this is what the pH probe looks like as a close-up. Now we'll be talking more about how this exactly works in the electrochemistry chapter, but again, I'm not sure if you're going to be able to see everything, but there's a wire inside here, which is a silver chloride wire, which is in a very low molarity solution of HCl. This essentially is detecting for a concentration difference. So there's a standard amount of H plus ions inside this electrode. You then put this little, very delicate glass membrane into a solution, and the solution then will be able to detect a voltage difference between the amount of H plus, which is inside of this, and the amount of H plus in your reference solution. Whenever you take a measurement with one of these though, the appropriate way to do this is of course not to move this around as a little as possible, right? We want to move this around very, very little. So the appropriate way to do this is to first rinse the electrode with what the lab calls copious amounts of water. How much is a copious amount? A lot, right? Again, I don't know what the volume amount is for copious, but you give this thing a pretty good squeeze and squirt on all of the different windows so that we don't have any of the other solutions that are in there to mess up our measurement. Using Chem wipes, not your fingers or paper towels, something that's nice and soft on this, essentially dab it all off, and then whatever you're going to take the measurement for, I just have here some DI water because I just have that as a reference solution. You then move this down into your solution and measure it back off. So that's what I'll be doing in the Logger Pro software. We're going to calibrate this thing, make sure we have the right overall voltages that it's going to be measuring, and then we'll do the measurements of our solutions for lab 6. So that's how all of the pH measurements go. Rinse it. Do not take this and jam it into the solution because that automatically will break these. So very delicate with how we make those measurements. So let's hop over to Logger Pro and calibrate this pH probe. Before we do this though, we need to calibrate the pH probe to make sure that it knows what the pH of solutions are so we can actually get the proper reading. So first thing we're going to do is go to Experiment and then come down here to Calibrate. And it's the only thing that's hooked up, so it's this LabQuest Mini 1, and it's the pH. So we're going to click that. It's going to give us a dialog box, which gives us 2 different places to calibrate. I'm going to use a pH of 4 buffer, and I'm going to ask that to lock that in as a pH, and we'll do it for a pH of 10. So I'll do the rinsing, and then I'll come back when we've got the reading stabilized for pH 4 buffer. Okay, so I have rinsed off the pH probe, and I have it now sitting in that little kind of rosé all-day colored pH of 4. So we're going to click Calibrate now, and we're going to wait until this reading here stabilizes. Now remember, we talked about how this pH probe essentially is measuring a voltage difference between the standard solution it has inside the stalk of it and then the relative H plus concentration outside. It works on the principle of what's called a concentration cell, which we don't need to get into now. Suffice to say, the higher the voltage is here, the larger the difference between the H plus concentration inside the probe and outside is. So a pH of 4 is a relatively low pH, which means we have a very high, relatively speaking, H plus concentration. So we expect a larger difference between the H plus concentrations inside and outside the probe, which is what this difference in voltage is showing you. So 2.30, again, I probably would like this to be stable and not moving around for maybe 10 to 15 seconds, and I haven't seen it move yet since I've been talking. So I think we're good here for the pH of 4 as having that relative voltage. So now we're going to tell the pH probe, hey, if you get a 2.30 or 2.301 voltage, it's pretty stable. That represents then a pH of 4. So we're going to enter here the pH reading. It's very common to enter the voltage reading here accidentally. So now you're going to put in 4.00 and you'll tell it now keep that data point. Okay, I'll rinse and put on a pH of 10, and then we'll have this be our second calibration point. So I've rinsed off the pH probe. I have in there now the pH of 10 buffer solution, and as you might have been able to predict, because the pH of 10 is a high pH, that represents a low H plus concentration. So now this probe is detecting a very small difference, or at least smaller than at pH of 4, a smaller difference between the H plus concentration inside and outside. So now the voltage is going to drop because there's a bigger, or sorry, there's a smaller difference between the H plus concentration, smaller potential difference. For whatever reason, the pH of 10 usually takes a little longer to stabilize. So we're going to let this sit here for a bit, and I want to make sure that it gets a nice low pH. A very common error here is to get impatient with this part of the calibration and not let this bottom out essentially. So I like to give this a 3 or 4 minute amount of time before it actually decides on what the final voltage is. So I'm going to prepare some other solutions while this thing finally decides on its lowest voltage. So we'll rejoin in a second. I'm feeling like it's about settled on this voltage here. So I think we're good. The pH of 10 has now calibrated the voltage for the pH probe. So we're going to enter here. Again, you enter what the pH of this is, not the voltage reading, 10.00, and now we'll hit keep on that one. Okay, so now the pH probe now has two different readings, one of which was a low pH, one of which is a high pH, and now the LoggerPro software has made a line of best fit between those 2 points. So any voltage it measures now for our solutions coming up in parts A, B, and C will be applied to that line. The voltage the thing is reading then gets translated into a pH, which will show up over here. Okay.